Hello, welcome everyone. We're excited to have you here all today. Before we get started with today's introduction, we're going to open up a short poll to learn a little bit more about today's audience as we go through our introduction. While we pull that up, thank you for attending today's seminar focused on GIS and ADA compliance, advancing accessibility across the US. Ecopia is thrilled to be collaborating with ConnectMe, today's participants and sponsors, to continue to support the GIS for state and local government asset management series. My name is Bill Singleton, Senior Leadership here at Ecopia AI, and I will be your host for today's session. My objective at our organization is to support communities and civil engineers in their objectives to make communities safer, more accessible, and equitable. All of our participants today are working in several aspects of the data collection, educational, and implementation ecosystem to support ADA objectives. Ecopia AI, along with our supporting presenters, have supported hundreds of communities and state governments across the US in their efforts to improve equitable, safe access to transportation infrastructure across the US. We look forward to all of your questions towards the end of today's sessions. So why is this topic so important? The U.S. Department of Transportation describes transportation accessibility as the ability for all people to reach the destination they need to visit to meet their needs. It is characterized by equitable access to transportation for everyone while preventing discrimination against individuals with disabilities. A transportation network that is accessible allows people for all abilities to participate fully in various aspects of society, such as employment and recreational activities. Unfortunately, millions of people across the US experience transportation inaccessibility. The US DOT recently found that up to a quarter of all transit stations across the country were reported as inaccessible. Issues with mobility infrastructure and essential features such as curb cuts, intersections, sidewalks, and crosswalks contribute further to accessibility challenges. Despite the crucial role that accurate, comprehensive, and up-to-date geospatial data plays in realizing transportation accessibility, numerous metropolitan planning organizations and departments of transportation struggle to acquire and maintain the geospatial data needed for planning and creating safe and equitable transportation network. To effectively evaluate and plan for transportation accessibility, highly detailed mapping data is required to plan and reflect dynamic network elements. As you can imagine, it can be challenging to get detailed data for determining and planning transportation accessibility. This topic has never been more relevant with the accessibility of federal funding through 2021's IIJA funding, which has both planning and implementation components for communities to access over $1 trillion in funding to improve transportation infrastructure and transit hubs across the country. A few of today's objectives and what we hope are key takeaways for everyone on today's call. We want to discuss updated ADA compliance requirements so that we can understand the latest in ADA regulations, using GIS as a tool for ADA compliance, learning how GIS, image processing, and LiDAR technologies can be utilized to enhance the precision and efficiency of ADA compliance assessments in public spaces, and most importantly, strategies for implementation, gaining insights into practical strategies and best practices for integrating these new ADA standards and GIS technologies. And in overall general, how we can build more inclusive communities to foster more accessible, inclusive, and technologically advanced communities. While we finish up the poll here, I wanted to do a quick rundown of today's agenda and our speakers today. We're going to get started with Jeff Powell, whose presentation I'm most looking forward to. He'll be detailing a real-world example of how Janesville, Wisconsin leveraged GIS technology for ADA compliance, starting from the audit process through the transition plan covering over 3,200 intersections and 340 miles of roadway. We'll then pass it off to Nicholas Milofsky, the director at Bad Elf, and this presentation will highlight the critical role of municipal ADA transition plans to enhance community well-being, and most importantly, how to secure some federal funding opportunities. We'll then go over to Brandon Yates, founder and CEO of Deep Walk Research, whose organization represents an iPhone-based LiDAR system to help with the precise collection of detailed sidewalk and curb ramp condition data, which is then scored with public right-of-way accessibility guidelines. We'll then move on to Esther Bolin, GIS manager at HDR, who will be discussing best practices for becoming familiar with available help resources to aid communities in streamlining implementation while ensuring digital products satisfy both federal and state requirements. We will then wrap up with David Wasserman, who will be talking about pedestrian planning beyond ADA and how future applications of GIS data can help support a number of transportation, safety, and equity objectives. We're most looking forward to the Q&A session toward the end of today's session, and we can, with our today's esteemed panel, being able to take all of your questions. So before I hand it off to Jeff, I'm hoping that we can take a quick look at the poll results. So as we can see today, we've got a huge amount of individuals from local government. We're really excited to see that. I know that there are a number of different programs that are available for local governments in order to apply for new planning efforts and also on the implementation side. So we're really excited to have the opportunity to discuss everything today. And just to see where everyone is located, a vast majority are located in the United States. We are excited because there are a number of grant programs that are available in order to be able to support these kind of objectives. And we will be covering a number of requirements across transportation and also planning, but this also really goes into that public works and utility space as well. So excited to have individuals from all three of those areas. And it looks like we have a pretty even split between all the different sizes of communities. And I think that reflects that this is an important objective that affects everyone across the entire country. So without any further ado, I'd love to be able to hand it off to Jeff now, who can talk about his experience with Janesville, Wisconsin.
Good morning or good afternoon, depending on where you are joining us from today. My name is Jeff Powell. I'll be running us through this case study for Janesville, Wisconsin. I'm GIS Solutions Team Leader for MSA Professional Services. A quick background on MSA, if you're not familiar, we are a 400 or so person firm, greater Midwest area, 100% employee owned. We've got our roots back in 1930s, originally as a surveying firm and grew to now a full-size municipal engineering firm. So today we'll be discussing the City of Janesville case study. This occurred in 2019, and they were looking to chase down that ProAg guidance and compliance and create a long-term transition plan for their community. MSA was selected to facilitate this Title II process for them, following from compliance, doing the audits and assessments, conducting prioritization through the transition plan, and then into implementation. We use GIS throughout the whole process of this project, both in the planning, some preliminary asset management inventory impacts, as well as the data capture, and then wrapping up with reporting as well. MSA has been using GIS for quite a bit through all of its services, but specifically, we've been working on ADA compliance issues since 1991. We have a full team doing that work here. The city, unique to this project probably, is the city was hoping to be heavily involved in the assessments, understanding what all the intricate guidance required, as well as being able to keep up their own assessments into the future, knowing this may be an evolving process. So they were looking to do that work on their own. Probably our main role to help facilitate that was MSA was going to leverage their internal GIS platform and create the tools needed to do that work and help them guide the users through the workflow and other management tasks as they became kind of self-sufficient with this as we wrapped up our formal part of the project. So phase one here, planning and preparing for the work to be done. The first thing we did before getting too far into it was make sure we had uh, our basic key assets in the system. They're using ArcGIS Online primarily for a lot of their tasks, and given a lot of our prioritization weighed on these key public inventory assets, we were looking at verifying that we had things such as the public transit features, the bus stops, as you can see to the right, other public facilities, making sure we had mapped all of our schools, et cetera. Once we were able to get that into the map and correct any of those things, we moved on to our example of prioritization. We were looking at over 3,200 public intersections to cover, and they had about 340 miles of municipal roadway. They were looking specifically to run through those assets to audit curb ramps being one of the major challenges. They are they are hoping to have the prioritization not only just for the transition plan, but given the city was trying to take a lot on in the future, prioritizing those resources of completing the assessment, as well as knowing that this was going to dovetail with capital planning efforts and this was going to run a long time. So having a really detailed idea of priority was going to help them for other plan activities in the future. And in setting these priority areas, it was deemed a great opportunity to do some public engagement for where residents felt that prioritization was best assessed. So into GIS world here, in the desktop environment, what we started with here was to create our priority areas. Priority one, um, as a first step here, being a quarter-mile radius from these key locations here, City Hall, voting locations, and then they had done some prioritization of the bus routes themselves, so a primary and secondary bus route system. And you can see priority two areas, similar type facilities, and then an exclusion of any known rehab projects in the next 3 years. You can see the results at the right here. We have these kind of buffer areas that correspond to these assets that kind of give us an idea of the area we're talking about. Now we need to turn that buffer area into kind of an intersection analysis, right, of where these audits would be held. And what turned out to be the result here is our priority one area consisted of, about 1,200 intersections, quite a bit of sidewalk, and 189 transit areas. You can see those kind of brought into this buffered area on the map here. Priority two, still pretty weighty in terms of volume of assessments. You can notice the absence of kind of that priority one area within the map here. And we haven't discussed priority three, but those in general just became all the remaining areas that did not qualify under those prior criteria. Not too much there to worry about. You can see a few of them poking out in the map here. As far as getting this data, then you'll hear quite a few unique ways to capture data at this level of scale come up later today. But for this, to really have the city own this process in the long haul, they're going to leverage their existing technology. So we are deploying mostly mobile apps through their ArcGIS Online to get this work done. So you'll notice here the city staff were trained to perform the audit assessments, including all the measurements they needed to take, understanding how to assess each type of asset there. We created I guess it would have probably been Collector at the time, 2019, right? If you're familiar, now known as Field Maps, is where we did a lot of this work, tying the inspection to their asset in ArcGIS Online, accessing that through a mobile device to complete those inspections. And as well, they were able to discover quite a few additional assets in the field, right? So this is just another opportunity to kind of transect your entire city and notice other things that may be missing on the map. That could include hydrants, curb ramps that we may have missed. So we made sure that the application supported collecting other data just to be efficient with the time out in the field. More specifically, as I mentioned, everything was kind of carried through Collector Field Maps as we ArcGIS Online using tablets mostly. The assessment we had built was kind of customized to the city's needs. We knew what we needed to do from the ADA standpoint as far as measurements, photos, get a condition evaluation on that particular location, as well as any other notable observations for that particular asset. Given that data input from the city staff, we preset kind of an automation within the GIS that graded a compliance level of 1 through 3, which we'll cover here in a bit, to help them even further prioritize the areas to kind of assess project likelihood. So as we move into kind of digesting some of that data here, a lot of the project, this is quite a bit of volume to inspect with the city resources. So, of course, it was an ongoing project. It took a while, and given that, we needed a good way to monitor progress and do some good QC on the information. So, all this information, if you're familiar with ArcGIS Online, was fed into an ArcGIS Online dashboard, which monitored the progress and completion of these assessments. Help them understand some of the preliminary grading that is shown below here. So we're using also a web application, web app builder, and GIS to manage this for those office folks who are doing some of that review and QC on the data. That compliance grading I had mentioned was categorized as 3 tiers, and this was that automation we had hooked to those inspections. So tier 1 being a fully compliant curb ramp, for example, tier 2 being substantially compliant, tier 3 having several non-compliant elements to those things to help them further break that down. And again, really advantage of using the GIS here, right? We've got real-time data collection, efficiency of capture, getting a lot of these other activities, both for asset management, mapping, other things done while we're out in the field, both opportunistically and related to ADA. Not only that, this is a framework that the city can carry forward on their own, the living map, if you will, right? So updating the progress, updating based on compliance or regulation changing. As they do projects and things change, get rebuilt, they're able to update all that and kind of complete their inventory and have a really solid picture of their level of ADA compliance at any given time. So it kind of goes without saying, we rolled that into wrapping up the transition plan more formally following all those assessments. A big part of it was really trying to figure out how we take this very detailed ADA data and dovetail it into these CIP project planning process, right? We're going to overlay all these new considerations of ADA into how we think about your average street project, help drive those priorities. Does that change those project priorities, things of those nature? So really using GIS to sort that out within their system. And then again, just following really ongoing maintenance, probably the best described, making sure all that data set is maintained and ongoing work is categorized and tracked in the GIS. That's about as much time as I have to cover a project of this scale here. So I'll be passing it on to Nick Smolvolsky of Bad Elf. Thank you for joining us today.
All right. Thanks so much, Jeff. Hopefully everybody can hear me. Wonderful start to this presentation and this webinar. Just want to say thank you for everybody that is attending today as one of the series sponsors. It's always warms my heart to see this type of active participation, and thank you for all our guests as well. Today, I'm going to be talking a little bit more about ADA, transition plans, and kind of more importantly, in my perspective, is how can we leverage advanced mapping technologies to kind of augment, assist, or even, complete ADA, processes faster, more, reliable. So I want to just hit home a little bit more, just really drill why ADA is so important, this American Disabilities Act, and how it really encourages positive growth in our communities. I want to talk to everybody quickly about who Bad Elf is. If you have not heard about us in the past, we're a GPS manufacturer that does also, geospatial consulting. We'll also be talking about, like I said, advanced mapping technologies, and I'll try to encourage you all if you have not done an ADA transition plan for your state and local government, municipality, you might be able to leverage some of these technologies, such as the presentation after me with Brandon and Deep Walk. And then we'll talk a little bit about how to get to that solution. All right, so before we go any further, there is going to be a solutions poll on your screen, basically asking if you are interested in any type of solutions wrapped around ADA. Do you currently implement a GIS solution for your ADA compliance? Are you interested in implementing a GIS solution? And if you do have a GIS solution, would you be interested in potentially maximizing it? And last but not least, do you need or do you use any type of GPS to do your data collection? So I'm going to let this poll run for a little bit. My presentation is short, and we'll come back to the answers at the end. Thank you for filling that out. This presentation is definitely about ADA for the right-of-way. That if you're not so familiar with ADA, if you're newer in this industry, obviously there are ADA guidelines outside of the engineering of our built environment. Today, most of our presentations are about equitable access, of being able to walk around and navigate your community. Usually ADA lots of has to do with sidewalks, the angles of the ramps, the pressure of walking systems when you have to press the crosswalk. So if you are unfamiliar, just to kind of really hit home, we're really talking about mapping and analyzing these sections throughout your city to make sure that people can, equally, equitably navigate across this without having injury. Just to hit home more of this important, about 57 million people in the United States have disabilities. That's about 19% of the population. 8.1 million people have difficulty seeing. 2 million people are blind or are unable to see. 7.6 million people experience difficulty hearing. 31 million people have difficulty walking or climbing stairs. If you can imagine that, if you were one of those people I just talked about in that demographic, if you were walking across an intersection, a busy intersection, and it had a lot of bad crosswalks, can you imagine how awful that would be? So we really want to do ADA compliance. We want to have an ADA transition plan in place because we want to ensure inclusivity for all residents. Municipalities must comply with ADA to create an environment that is accessible and welcoming for everyone, including people with disabilities. Hitting that home, supporting disadvantaged populations by adhering to ADA standards. Municipalities actively support disadvantaged groups, helping level the playing field and provide equal access to public services, facilities, and opportunities. I think sometimes we probably take it, we probably just take it for granted that it's, if you don't have a disability, how easy it can be to navigate. And I think this is just a really important thing for our society as a whole, to be, fair to everyone. And there's also a financial piece to this. So you really want to also avoid legal or financial consequences. So maintaining this ADA plan can really help with that. But that also promotes a positive reputation as your community, a community that actually values its constituents. So at the end of the day, investing in this is actually investing in a place where people want to live. So something to be proud of. I mentioned about Bad Elf. You can see one of our GPS units there on the right. We've been around about 14 years. We create global positioning systems, or GNSS nowadays, global navigation satellite systems. We live in the world of what's called BYOD, or bring your own device. So you GPS, or basically fire our GPS up. You connect it via Bluetooth to your Android and iOS or Windows tablet or phone. You could connect peripheral devices like laser rangefinders or other types of digital bubble levels. But effectively, you open up an app like Esri Field Maps, or maybe even something like Deep Walk, and you're augmenting the position of your phone or your tablet with high accuracy. We have two main product lines, the Battle Flex and Flex Mini. I'm going to suggest that if you're interested in the kind of nuance of the high accuracy GPS, I'll be reaching out after this webinar to anybody that was interested in the polls. But we have a fully survey grade option and a close to survey grade option. Now, when we're talking about ADA transition plans and ADA levels and slope and all the different types of measurements, it has to be at a high accuracy. So just to throw it out there, that if you are considering using GPS to actually take measurements on your sidewalks and things, it has to be what we would call survey or engineering grade, or it's not going to be accurate enough. But even then, having a GPS that's accurate enough to place you in the actual sidewalk panel So, you know, I'm assuming Jeff probably ran across in his great presentation with MSA, he probably found areas where his GPS floated outside of the sidewalk, right? And, you know, they probably had to rectify for that. So having a higher accuracy GPS could mitigate that. So I do want to talk a little bit more about advanced technology. So one thing I want to talk about is all good geospatial data needs an accurate point of beginning, or what we call in survey land a POB. This is to mean that you need the cornerstone, so to speak, of your GIS to be based in high accuracy data. You know, CRUD in is CRUD out. Well, to create that base map or that ground control, you know, this is where Bad Elf comes in. So the high accuracy GPS provides the geo reference, the ground control to make sure that these measurements are being done accurately. So the other thing to mention is that all geospatial data are stackable, right? So we all understand the layer cake analysis or layer caking of GIS data. Well, if you have a strong set of geodetic control, say set by GPS, and then you want to use alternative technologies, so maybe you're not trying to measure out your sidewalks with an actual level on each panel, right? Because that's kind of how Jeff was explaining. But imagine, you know, one of the projects I worked on, it was a 4,000-mile transition plan for the city of Tucson. That's a lot of panels to manually measure. And so thinking outside of the box, we can adapt new technologies like LiDAR and laser scanning and drones. But all these data are still stacked upon the high accuracy, you know, from that initial base. You can see here on the right, this is one of our customers that attached a GPS to an e-bike. They ride the e-bike up and down the slopes, and it is accurate enough to actually take those measurements. So terrestrial speaking, you know, yes, GPS asset locations. Where is the pole with the push button? Where is the crack or the heave that you're looking at? Or if you have high enough accuracy GPS, you can actually, you know, create a slope rating to see if it's within spec. Smart device photogrammetry. So your cell phones these days can actually do a whole lot of stuff. Pix4D, VGIS. You actually use your photos to create 3D meshes that can then do measurements. LiDAR, so light detection and ranging. Not as new these days. Most people are usually familiar with it, but you have static ones where you set up on like a tripod, or mobile where you put it on a backpack or you drive it on a car. I mentioned earlier VGIS and Pix4D, but augmented reality, the ability of using your device to start remote sensing. Or if you're going off the ground, you can go aerial technologies like drone imagery and LiDAR, right? So I've actually seen ADA plans now where drones will fly over the areas and it's collecting all that data kind of in a big point cloud format. And then you're using technologies or people in the office to collect the data, to extract the derivatives of the data. Same thing with fixed wing imagery or LiDAR. It's just at a higher level. And then there's also a new technology out there called SAR, synthetic aperture radar. So imagine that SAR usually is on satellites, but with some good ground control, with like from a GPS again, you can actually do measurements from space, and it's pretty neat. Some of the applications that are coming out from SAR. I mentioned these kind of point clouds. So if you're using LiDAR or photogrammetry, you're creating a 3D, almost digital twin of the world. Using artificial intelligence and or machine learning, we can actually go in and start extracting out a lot of those data. And in fact, that's my background. So I've done probably about 35,000 miles of ADA transition plans. And what I mean by that is I managed teams that did that. We had mobile LiDAR trucks at actually 2 different companies that would go out and collect entire cities. So massive swaths of data. And you can see in the lower right hand here, this is a point cloud. So that point cloud comes out, and then we would actually use AI to pull out a lot of the ramps. And so you can see here the digitization of these ramps in the lower left-hand corner. So the AI actually did about 70% of the work, and then my in-house staff would actually pull out the remainder of the work and QA/QC it. So again, imagine collecting a 1,000-mile transition plan. If you had to walk that whole thing, that could be pretty difficult. The idea here is, how do you scale your technology to your city? If you're just a small city, maybe you use a backpack LiDAR, or on the right-hand side there, you see a phone attached to another GPS device. Again, I don't want to get ahead of myself, but Brandon's going to be talking about Deep Walk here in a minute, and that's a pretty neat solution where you're not actually having to use a digital bubble level. And I just want to throw it out there that I spent an inordinate amount of time with Bentley, if you know Bentley software, and their engineers and the LiDAR technology, the company we were working with, to actually qualify how these lasers can get so accurate that you can actually collect small degrees of measurement. And then for fun, I put Spot the robot dog on the left-hand side there. Imagine you had to do an ADA transition plan in an extremely busy place that was maybe dangerous, maybe adopting a new technology like that. I mentioned drones. You can fly over and scan these things, or even satellites now. So there's a lot of opportunity to use these new technologies to collect very large amounts of data for ADA at a very short amount of time. I'm just going to highly encourage everybody. You've got to have really good data in to get good data out. So set your ground control, set your GCPs, set that ground reference, and set it up really strong so that all the data that you're producing downstream are coming out the way you want them to. How do we get there? I'm just going to wrap up because I'm out of time. Bad Elf, we have a geospatial enablement team. That's what I run. We come alongside our hardware to help support you. So if you're using our GPS, you're not just getting it and having to figure it out on your own. We like to get you to zero to hero quickly. So if you need to do an ADA transition plan, you want to talk about GIS, you want to talk about GPS, we have the actual experience in-house that we can help you get going, or at least connect you to some of our partners if it's necessary. So let's go ahead, poll results very quickly here. So let's take a gander. It looks to me like currently, it's not a bad breakdown. So about 32% of you are saying that you do have a GIS solution for ADA compliance. 45% of you are not currently using a GIS, which that to me is a total amount of greenfield where everybody can enhance their systems. Rising tide lifts all ships. Are you interested in implementing? 21% say yes, 38% say maybe, 16% no, or 25% you're already doing it. That's awesome. And if you have a GIS solution, would you be interested in trying to see if you can get any better? Most of you said no. That tells me that you probably have some pretty awesome GIS people out there, which is awesome. Invest in your employees. And do you need high accuracy GNSS potentially in the future? Pretty equal breakdown. 40% say yes, 39% said no, 21% said not applicable, don't want any of that. So thank you so much. That's what I have. I ran just a minute long. I will be reaching out after the webinar and sending out some information. So if you need any help with GPS or solutions, or would like to talk to any of our other partners here, let me know. Without further ado, Brandon Yates is going to be up next. Brandon, do you want to take it over and I can stop sharing my screen?
Record.
All right. Thank you so much, Nick. Really excited to explore the GPS sensors from Bad Elf because it does actually overlap with us pretty well. I'm Brandon, one of the co-founders of DeepWalk, and our goal is to make ADA compliance simpler, at least for municipalities, universities, DOTs, and the consultants that work with them. There we go. There we go. Perfect. So the basic ADA requirements are if you have more than 50 employees in your municipality, including part-time, you're required to do a self-evaluation, so some sort of proactive assessment of your sidewalk system, and then use that information to make a plan to address the issues that you found in your self-evaluation. And this has been a huge challenge for municipalities across the country. Less than 11% of communities in Illinois, as of 2019, we've been working on it, have a recent self-evaluation and transition plan. And this fact has led to massive lawsuits across the country. We like to throw the big headlines in there, but there's also small communities. And also different grant applications are requiring the submittal of transition plans. And supposedly there's supposed to be some more requirements on state funding. We'll see if that happens. But the public right-of-way accessibility guidelines, so like it's been mentioned a couple times, these are the accessibility rules for sidewalks next to streets, essentially. They were originally written in 2011, and then they were updated and finalized on August 8th of 2023. And they're very, very, very close to being adopted as the formal standard, like the enforceable standard. And that's leading to essentially more uniform enforcement across the country. This self-evaluation process has been a huge challenge for municipalities. Going out and doing the measurements by hand is very labor intensive. The training is complicated. And then a huge issue that we found is municipalities would go and collect all the data by hand, but they didn't have a way to keep it updated. So then 5 years later, they sort of forget about it and somebody retires and they go and do another one. So that's a huge challenge for municipalities. Another one is getting the data you collect over to specific work orders, because a lot of times you end up with a picture and maybe a maximum slope. It's very challenging to make a decent cost estimate or get your quantities or make a trip hazard program from that type of information. So that's what we set out to solve. We're a team of computer science and civil engineering graduates from the University of Illinois. We're based out of downtown Chicago currently, but we have projects across the country, and we have an advisory board of nationally recognized accessibility experts. And we built a scanning software using the LiDAR sensors on the new iPhones. And you just take our 20-minute online training, and you can either download the app to your device, or if you don't have one of the qualified devices, you can just rent the iPhone from us. Most of our customers do the rental. And you scan your sidewalks, and we go through the basic public right-of-way accessibility guideline points, you know, the most critical ones, and we make a variety of reports, maps, and deliverables to make creating and implementing your transition plan a lot easier. So this is what it looks like in practice. You just sort of point at the sidewalk and scan it until it turns green. There's also a manual tagging feature that allows you to customize the data being collected if there's something you want tagged that we don't automatically collect. You can get anywhere from a mile to a mile and a half per hour. And what we're doing is making these 3D models as you're scanning. And we have some machine learning software that cuts out the panels and it checks the slopes and the widths and the detectable warnings and the basic ProAg requirements. And it puts it into two places. We have a really strong Esri ArcGIS integration, and 100% of our customers 39 municipalities have used it up to this point. And we also developed our web application about 6 months ago. And this allows non-GIS stakeholders to be able to access the data and not be 100% reliant on the GIS team to view and access the information. So this is our details page. It's just a good way to see how detailed this information is. So this is a top-down view of one of the scans, and every single panel is cut out, and then we drop an icon anywhere that there is an issue. So you can see some cross slope issues, run slope issues, some trip hazards, there's an obstruction, and we collect a lot of information and put it in here for you. And then we have 3 different GIS mapping files. One of them, they're essentially different scales. So you'll have like a curb ramp and mid-block type layer that's more zoomed out and has more aggregated information. And then we also have individual features like trip hazards and panels with high cross slope. They all have their own features, and you can just flip through those features to see which one you want to use. Currently, it's available for download from the web application as a GeoJSON or a CSV. And another nice thing about our files is the actual imagery is attached as a pre-signed link. So that's hosted over in DeepWalk, and it makes your hosting requirements very low as you're building out your ArcGIS deliverables. We also have a 2-click ArcGIS integration. Essentially, you log into our web app, you authenticate with ArcGIS Online, and you click Create Web Map, and it makes 7 different ready-to-use fields that are pre-formatted. They already have a custom, or 7 different layers, and they're pre-formatted. They've got ready-to-use pop-ups, and it's all set up for you, so you don't have to start from scratch from a shapefile. If you're using this information, it saves a lot of time. And we also have our web application. Some benefits to that is you can customize the data being collected. It allows for continuous delivery. So as you're scanning and we finish quality control, you're getting batches of 25 inspections at a time. And it also simplifies project handoff externally. So say if you have a consultant doing the data collection, they can just give you a login to your project on DeepWalk, and everybody at your organization can access it. And then also internally. So say if everybody here retires next week, it'll be easy to hand the information off to the next person in line, and they'll be able to hit the ground running. I want to talk about our new implementation features, and it's something we're super excited about. Sort of our philosophy is if the data doesn't end up in a work order at some point, then it's not worth collecting. So this is kind of what we mean by that. We have an implementation process where you select an area, get your recommended programs, create and review whatever recommended program, and then export the work orders. And you can do that within the web application. You can also do it in ArcGIS Online. So this is a dashboard, select an area. It gives you some high-level information, but if you scroll down to the bottom, it tells you which programs would have the biggest impact for that area. And then you go and select whichever program was recommended. I'm going to pick obstruction removal because it's my favorite and it's cheapest to implement. So here's all the locations where vegetation is overgrown onto the sidewalk. You can filter by severity, essentially the clear width of the sidewalk. Select that area. It's all geocoded and you have the images and top-down views and all that good stuff. And then you just create a program and name it. And then when you're done with that program, it shows up in its own little dashboard where you can download mapping files specific to that project. And you can also download some ready-to-use documents. My favorite is the door hanger. So traditionally, the way a vegetation removal program works is you select all your addresses that have vegetation growing on the sidewalk, and then you send out your maintenance folks to go and put door hangers on the homeowner's door and just ask them to nicely remove their vegetation. So this is our philosophy on transition planning, is making sure every piece of data we collect ends up in a work order. The way our projects work is you take our online training, takes about 20 minutes, and we build a device to you, or you download the application, and then you scan. While you're scanning, we're taking care of quality control and technical support, and then you just view the data on the web application. We bill per mile, so it's flat pricing. It's the same every time, and most of our customers year, and it keeps your data up to date, and you don't end up collecting 50 years worth of data. And continuous use is 10% of your total data collection cost annually. And I have some interesting projects I can dive deeper into in a follow-up meeting or in the Q&A, but Highland Park, Illinois was a good one. They have 200 something miles and they're doing all their inspections over 5 years. So they did their first one last year and it was really interesting. They used utility box custom tags, which I thought was interesting. And then Corinth, Texas was an interesting project because one of our data collection partners flew out to Corinth, inspected 255 curb ramps in a day and a half, and then flew back, which is very fast for anyone who's done this. And the best ways to get started with us is we have a pilot program. There's a 1 mile, a 3 mile, and a 5 mile option. You can go and scan over your lunch break and see if it's a good fit for you. And we're also very fast at turning around cost estimates. So you just give us a number of miles or a number of ramps that you inspected, and we'll give you a quote within 24 hours. So that's it for my presentation. I look forward to hearing your questions in the Q&A, and you'll get a follow-up email from us as well if you want to set up a demo and maybe look a little deeper into the data. And our website also has a lot of interesting information, and that's in the resources tab. So that's it for me. Thank you for attending, and I'm looking forward to Esther's presentation from HDR. Thank you. Thank you, everybody.
Hi, everybody. Let's get my screen up here. All right. I am Esther Bolin. I am the GIS manager for HDR in our Denver office. HDR, just for a little background if you're not familiar, is an architecture, engineering, and construction firm. We are 12,000 strong these days with 200 offices worldwide, so we're a fairly big operation. I'm going to be kind of bringing us out of the physical space and into the digital space as far as how ADA compliance is done in the digital space. I'll be discussing that intersection between accessibility and the digital environment that we all live in more and more. Many of us are familiar with ADA compliance in the physical world, but accessibility in digital deliverables tends to be overlooked by everyone, essentially. In particular, I'll be discussing Section 508, which is an executive order that seeks to remove those barriers that are often overlooked. So what is 508? So there's a lot of overlap between Section 508 and ADA, but it's not the same thing. 508 compliance mandates equal access in digital spaces and focuses on access for individuals with visual impairments, including CVD, which is color. It's essentially color blindness, and also low vision. So it currently only applies to federal projects. It's a federal standard where it's an executive order, but some states like Colorado have adopted this executive order. So even though we're not functioning in the federal space, we're still following the same rules, which means that when HDR creates products for the state of Colorado, we are following all of the 508 standards. So right now, just in the federal space, but it's nice to see states adopt these more and more. And I think that as we move forward, it's not just going to be states, but it'll be smaller local agencies and then hopefully private agencies as well. So how do we define the digital space? The digital space is essentially all of your deliverables. So your project information, your email, web pages, websites, attachments, reports, essentially all of your communication that is happening on a project, be it an ADA project or otherwise, all of it falls underneath this umbrella and has to meet the 508 compliance. So you can imagine a large project, how many emails you're generating. Are you pushing up a web page to a client, all of your attachments, all of your figures, everything inside of your report, it all has to meet these standards. So there's a big downstream effect when you start to think about compliance and then applying that compliance to the entirety of your project. So 508, it really focuses on visual accessibility. So CVD impacts a significant number of Americans, but it's something that we overlook when we're creating digital deliverables many times. Particularly in just simple things like sending a figure to a client. We're not thinking about the fact that there are, 1 in 12 men and 1 in 200 women who may have trouble accessing or having access to that product that you created. So the challenge that it creates is that we can't just rely on color to parse information anymore. And that's a habit that a lot of us have, myself included. Especially on a complicated figure or a complicated map, we tend to use color to differentiate, and we need to rethink that. So instead of relying on color, what are the other methods that we can use? In addition to the color disability, there's also 50 million Americans that live with some amount of low-grade, low vision or partial blindness. As was mentioned earlier, in Nick's presentation, that's many, many Americans. So we're trying to be as accessible as possible. And digital creators, in my mind, should be developing with this in the back of their minds at all times, that there are folks who may not be able to consume their material. So how do we put Section 508 compliance into action? It's a little bit of a long road. It's a relatively new executive order. It came into action in June 21st of 2021. So a lot of organizations are still finding their way. What I'm going to follow up with is an overview of how to implement the accessibility requirements, some brief examples of best practices, and then just a couple of help resources that we've discovered that have been really guiding the way that we are implementing this. I like this particular slide because these two maps are a great example of the base map on the left. It's fine, it's something I would look right over, but it is terribly inaccessible to many people. So the example on the right is the same area, but it's just the cartography was created with accessibility in mind. And even to folks who don't have visual impairments, I immediately prefer the one on the right. It's a lot easier to read versus the one on left, but this is a good example of how different it can be, like how different the experience can be when it is made accessible. So a roadmap for your GIS, be it yourself or someone within your organization, we found it useful to just kind of think through it step by step. What is it that we are going to need to do to be effective? How could we do this in a cost-friendly manner? How could we share all of this information? So this is kind of a brief example of the roadmap that we used. So first, we wanted to identify the internal needs, asking yourself that question, which of my projects apply? Which of my products apply? Is this a mandate that is being adopted by the state, even though it's just a federal mandate currently? Is my state, does it have it on their radar? So these are things to start by asking, and then, take those next steps if you even suspect that any of the answers are yes. It's a good idea to kind of start looking deeper. So second, compiling some guidance resources and investing in internal training. There are a huge amount of resources already available, including the federal documentation, which is the Section 508 Gov. Also, software providers such as Esri have created, amassed just huge amounts of documentation for how to follow accessibility standards inside of Esri products, which is really helpful and really forward-thinking on their part. Organizing internal training sessions, yes, it's a time investment and it's a money investment, but it really ensures that continuity in the implementation and is going to enforce your best practices. So yes, there's a cost associated, but we found that it was more than worth the effort. Next, I would say develop some repeatable workflows and really focus on making those available to everyone, but then also, also developing some tools and then disseminating those tools to all of your staff. So these resources are going to save time by avoiding that duplication of effort. Like you have two groups of people who are trying to solve the same problem, and they may solve the same problem the same way, they may solve it a different way. So just making sure that there's standardization early is going to pay off a lot. Keep the resources brief and easily consumable to all audiences. I get really excited about style files because that's something that I use all the time in my day-to-day. If I were to push those style files that are specific to Esri and ArcPro in particular to folks who are not GIS staff, they're not going to care. They're going to overlook it. So just be mindful of who your audience is as you're starting to disseminate this knowledge. Lastly, keep in mind your non-GIS staff. So reach out to folks who are maybe not going to be creating those digital deliverables, but empower them to recognize what is compliant versus what is not compliant, when and where this executive order might apply to them. And that's just going to help you avoid that single source of expertise. You don't want one person, you don't want one or two people who are really great at this. You want to make sure that everyone kind of has this on their radar. And when a project is just getting up and rolling, that's the time to start making those decisions instead of getting too far into your project and then having to backtrack. And we've been there before and it's not great. So let's talk quickly about kind of what this looks like in practice and what this looks like from a GIS perspective. So we'll talk about a few of the design principles. The first, I think, is the most low-hanging standard and really easy to achieve, is color contrast. So making sure that your contrast of a font on top of a background is high enough that it's going to be discernible to someone who either has trouble differentiating color or has low vision. So there's a really great resource called WebAIM, and you can put in the hexes of the colors that you're trying to use, and it's going to tell you what that contrast value is and whether or not that contrast value is meeting your accessibility standards. So it takes out guesswork right there. I mean, that's a hard thing for me to guess if I'm high enough contrast, so I use this particular tool a lot to make sure that we're headed in the right direction. Black, white, and gray are always great places to start. So you can see in these two examples in the what to do, that's black, white, and gray. They jump right out. They're easy to read. I also recommend just test printing in black and white, it's a really good self-check and will give you instant feedback on whether or not that color selection is good. If it's got a lot of contrast, if it's easy to discern, you're going to need to look at your colors a little bit more in depth, but just that quick print is a great way to be on your way. So this is two examples that demonstrate kind of the high and low contrasting colors. And you can see that even folks without any visual impairment, those examples on the right are not great, particularly the red and the blue. That's really hard to discern. So a lot of these principles, even if they're not geared to folks who have the impairment, it's going to benefit everybody. It just makes for a higher quality product. Another one is font rotation. So it's not something that we're always thinking about, but particularly folks with low vision, they're going to have difficulty differentiating in font rotation. So if you're angling past 90 degrees, that's going to be harder to read because of the way those letters stack on top of each other. So it's not only a good cartography best practice, but it's a good best practice for anyone that you're designing for that may have accessibility issues. And you can see in these two examples, you immediately prefer the one that doesn't have the kind of odd looking rotation. So quick and easy thing to implement and just something to have your cartographers thinking about. Another quick example is text overlap. So where text overlap is discernible to me, there on the right, I can tell what those two are. Anyone with low vision, that's going to be more of a blob. Also overlapping with your map elements. So you can see the name of the road is overlapping with that purple line. That's something that I can differentiate, but other folks might not be able to. And again, this stuff just pays dividends in creating a better cartographic product. So good things to just keep in mind. As far as resources, this is by far my absolute favorite resource for color picking. It's a favorite among most people who are making maps because it's going to give you some ideas for color ramps that are going to be compliant right out of the gate. So this tool can filter for colorblind accessibility and will suggest color ramps. You can see over by only show, there's a little button that says colorblind safe. You select that button and all of these color ramps are going to change to make sure that they're accessible. It will then give you that list of hexes that you can just bring into whatever program you're using. You can import those, zero guessing. They tend to look really nice together. They're well chosen, and it's a really quick way forward to get past that color hurdle. I think a lot of us struggle, myself included, with making sure those colors look good, but that they're also accessible. It's a tough thing to learn at first. Here's a screenshot from Esri's Arc Pro, and they embedded a nice little tool. It's called the Color Vision Simulator. So as your GIS professionals are creating figures for you, you can see that in this example on the left, they chose a blue, a green, and a purple. Those look lovely to me. But when you go into the Color Vision Simulator, you turn that on in Arc Pro, you can see that now we have kind of two shades of teal that are really difficult to differentiate, and then just kind of a bland little purple brown line moving through all of it. So this tool it's really handy where it's embedded, but then it's also going to give you a really fast check to see if your color selection is holding up. You can also select through the different kinds of color blindness and the limitations and how it's going to look depending on which limitation the user has. So great quick tool that is embedded right there in Arc Pro. So just to wrap up, some key takeaways. I think it's far past time that the digital creators, all of us who are digital creators, are designing with accessibility in mind, even when it's not mandated. In those examples, like the font rotation, it's going to make for a nicer product, even if you're not being mandated to do so. The digital space should be much more accessible in my mind, even than our physical spaces, because we all spend so much time in the digital space now. Prepare early and take time to coordinate with your whole project team to make sure that everybody is on the same page. They know what's coming. You don't have to revisit anything. Design your digital products with a purpose-first mindset. So what is this map trying to say? What's my important information? What's my not so important information? This will reduce the number of iterations that you need to achieve compliance and achieve that nice looking product. Less is always more. When in doubt, subtract. The more simple, the better. That's just almost universal, right? And then test, test, test. Just keep testing. Lean on resources that are going to speed up your testing, like the contrast checker, like Color Brewer, like the embedded tools within Arc Pro. It's going to make sure that there's not something that you're missing, shows up later. You have to go back, make those changes. And this is especially important in maps, where maps tend to be a little bit more dense and there's a lot of room for error in there. Lastly, maps should be understood and usable by everyone. So these are resources to get you there a little bit quicker. So that concludes my quick overview on accessibility in our digital spaces. Thank you for taking the time. I look forward to any questions you might have. Next up is David Wasserman with Alta Planning and Design. Thanks very much.
Well, thank you everybody for bearing with me as I share my screen. Excellent. So thank you. My name is David Wasserman. I'm Alta Planning and Design Civic Analytics Leader. And I was going to talk about pedestrian planning beyond ADA, focusing on the co-benefits of these types of inventory efforts that come from ADA compliance, but also wider opportunities within data collection that can enhance planning for pedestrians in the public realm. And for those unfamiliar with Alta Planning and Design is a multidisciplinary firm focused on creating sustainable communities across the United States and Canada. We bring together engineers, planners, designers, behavior change specialists, and graphic designers to facilitate investments in sustainable mobility that are safe, equitable, and resilient to change, with a lot of our practice focused on active transportation for a very long history as a firm. And as others have already presented in this session, there are a variety of new technologies that people have mentioned where whether it's LiDAR data collection or enhanced reading of aerial imagery, using everything from data provided by providers like Ecopia to Esri's deep learning packages, the ability to get a scalable view of our context within the built environment is continuing to change. And as a result, the general ability to represent that built environment with digital twins is also changing, and it's giving us new repeatable methods, and they can enable more multimodal enhancement of our scenario planning processes when we're thinking about what types of facilities we want to build out for pedestrians. But also it has a lot of asset management inventory benefits. And there are a lot of advances in computer vision that I think enable us to think about how data collection might change for these types of data sets in the future, as we're finding models such as Segment Anything provided by Meta, and then augmentations of that with libraries like SamGeo and similar models provided by Esri. The ability to extract features either from aerial imagery and potentially future data sets that are more detailed, such as those provided by Deepwalk and others, might enable us to do a type of visual search as we're thinking about how we digitize assets. And while this might not be at the detail required for ADA compliance, there is more than just the detailed data that we need for curb ramp slope and sidewalk condition and width that can enrich the pedestrian planning process. And I want to give a few examples of those types of applications. So one is, the applications we'll go over include talking about network quality and connectivity, safety and vision zero, tree canopy expansion, and modal planning more generally, and what the wider opportunities are. So one area to understand where asset data for ADA data collection can be critical is understanding how sidewalks, their built context and condition influence the user experience of pedestrians. We know from behavior change literature the presence, quality, and context of pedestrian facilities has a strong influence over the choice to make a trip, whether it be walking or cycling. And one approach we can use is scoring areas of a city based on that idea, where you have a connectivity ratio, where you have an understanding of how far people can reach using the usable pedestrian network, but then you can adjust for that understanding based on the network quality. Maybe there's a major arterial that has no sidewalks, or there's only sidewalks on one side and no suitable crossings. All those things can influence whether or not people will want to make a trip. And so there's one type of methodology that can take into account sidewalk inventory data that might come out of a compliance effort that looks at both the sidewalk and roadbed width information and speed limit data from other sources to develop a pedestrian level of traffic stress. And this is an example in one community in Mount Shasta where we developed in a small town based off of these inventories an understanding of where segment level network quality was influencing the pedestrian experience, and use that to show what raw pedestrian connectivity looks like if you assume access via all facilities that pedestrians can walk on, versus an LTS weighted connectivity analysis where we looked at adjusting those walk sheds based off of our understanding of the network quality. Additional areas where these applications and relationships between these sets are applicable is safety analysis. In one case in Modesto, California, we used similar derived sidewalk and crosswalk data to bring a strong understanding of how the existing infrastructure related to the safety conditions near schools. During a deeper analysis of collisions, we examined the location of where pedestrians were struck and found those that were crossing the street outside of a crosswalk. 2/3 of fatal or severe pedestrian collisions occurred on roadway segments that had a greater than 800 feet spacing between crossing opportunities. And so this is just one example where these very same data sets that we're collecting, if we're able to integrate them into a larger context, can provide insights that would have been difficult to see in a more nuanced context. Another opportunity to think about is it's more as we look at entering a warming world, how pedestrians experience our cities is going to also be influenced by thermal comfort. And so there was one project in Sacramento where tree canopy inventories, while not are sometimes tangentially related to an ADA collection effort, if we're able to get a scalable understanding of where tree canopy is, where there are possible planting opportunities based off of the location of planters in and around sidewalks, it gives us an understanding of where we can provide more shade for pedestrians and then coordinate that with active transportation planning efforts. And finally, as we look at more and more comprehensive right-of-way data collection that can go on alongside or with other data sets from whether it be ADA compliance or beyond, there are opportunities to build a more multimodal understanding of our streets and look at the development of cross-sectional databases where we're able to enable, if we can think about a future where we have the ability to sketch out different layouts, show them in a interactive platform, be it a city engine, such as the images you're seeing here, or platforms like Beyond Typicals, and make it clear what the different what the different alternatives for a street could be, what the possible changes in their performance would be, and have this tighter coupling between the raw data collection that tells us what the option space for our streets are today and what they might be tomorrow, based on those types of models. And just one case study bringing these all together is Kansas City's sidewalk prioritization study. And this was a project where there were a lot of different considerations, like many cities are considering, of how do we make the choice of which sidewalks to build out and where. And when we look at transportation more broadly, you know, there's this increasing understanding that there are more and more goals that our networks are expected to meet, and more considerations than just whether or not there's enough capacity for vehicles to meet the needs to meet future needs that our streets are desired to meet within our communities. And Kansas City was very aware of that. As part of our work with them, we worked on an implementation tool where they were looking at balancing their budgets that they have for sidewalk expansion with the community aspirations that they had. And to address that, we looked at incorporating sidewalk gap construction in their capital improvement program, and developed a tool that helped them identify where there are high priority gaps, and adjust those goals, and do a very comprehensive prioritization to identify which goals they have, which sidewalks would fill in low stress, would provide more low stress access, which ones would address safety concerns, improve high demand, address high demand areas, and consider equity, sidewalk condition, and public engagement efforts as well. But they needed a way to look at how these different goals interacted and identify, alongside all of these different measures, how they would identify the best facilities. And so while there was a baseline prioritization score, we worked with Kansas City to develop a sidewalk prioritization tool where they could put in total budgets that they want to expend by year. They could pick a horizon year. They could identify what types of projects they want to address, whether it be gap or repair projects. And then they could adjust the weights of different goals to identify which sidewalk projects they want to fill in, based off of the budgets available and the weighted goals that they had. And so we would show a project build out by year, based off of their existing gaps or existing maintenance schedules that they wanted to address current deficiencies on, and enable them to show to community council districts and stakeholders what they could build out with what degree of funding, over what time horizon. And in terms of resources, a lot of my presentation is focused on what can we provide beyond just thinking about ADA data collection as a compliance effort. This data, the data that we're collecting, has a very wide range of potential applications and co-benefits if we're able to identify what's relevant to different stakeholders within your communities, identify how do you scalably integrate some of these more detailed data collections into a larger comprehensive database, and how do you tie it back to your systems of records, be it your centerline databases or otherwise, that enable you to do more with the data that you're collecting, and build a larger coalition for its collection. And so along those lines, I just wanted to share some resources about some of the influence of the changing technologies. There are various resources now within the American Planning Association talking about, at least within planning, where some of these applications and types of providers can provide insights to different data collection efforts, whether it be using Mapillary or some of the firms that are presented on this panel, but also I wanted to share a wider technology resource. One of the things that I do as part of the chair of the APA Technology Division is we work on something that we call the Urban and Regional Planning Resources Repo. And even if you're working in GIS, this is a good resource to understand potential data sets that might be available to look at these other different considerations that I alluded to as part of my presentation. And so I just wanted to share that resource. You can find it on GitHub and within the links that we have within the Zoom call. And with that, I want to bring together the rest of the panel to talk and address questions as we can. So thank you.
Bill, you seem to be muted. I think you're talking, but you're muted.
Oh, I'm so sorry about that. I wanted to thank everybody for joining today. Just do a quick wrap up. We've got a lot of great questions that I want to power through in the last few minutes here. And so just we'll go through in chronological order. I did want to quickly address Yah's first question. Really, the ADA is a civil rights law that prohibits discrimination of people with disabilities. And this goes through all public life, including jobs, schools, and a number of different other areas. Specifically in terms of transportation, I know Brandon specifically covered this. This is a growing concern, not just because of all of the lawsuits that are potentially coming in for larger cities, but also there's just such a great opportunity with federal funding that's now available if you have the correct data in order to be able to improve your communities and make them more accessible. So looking forward to going through the rest of the questions here today. I think one of the first ones that we had, Jeff, was for you from your presentation. And was there any difficulty in the format of the ArcGIS deliverable? And was there any lessons learned from that piece?
Sure, thank you. And speaking with the project team, it sounded like reflecting now in 2024 on a 2019 project, it's kind of amazing, as you've all seen today, how much there's out there to do this type of work. I would say just more generally, as far outside of deliverables, tackling the scale on a asset by asset versus some of these scanning technologies and larger integrations with doing some of the holistic analysis. So we'd be looking to incorporate those in the future. As far as deliverables, really no difficulties to note. A lot of the planning documents put together were assembled via PDF, right? So we're working in a web environment, collecting our data in ArcGIS Online, making sure there's all the correct connections and updates needed when we're talking about other things like asset management. But at the end of the day, right, that's coming out of that format and creating the exhibits and whatnot that help support something like a transition plan. So pretty seamless, even, way back in 2019, if I dare say it.
That's great. Thanks a lot, Jeff. So this question looks like it's for Bad Elf. And so how was the workflow integration with the Navis scanners?
Yeah, so it depends on what you're trying to integrate. If you're trying to get us directly integrated into Navis, we have our SDK available on GitHub, and we do custom integrations with third-party vendors all the time, peripheral devices, LiDAR, scanning, obviously, or utility locators, laser rangefinders. So you could certainly reach out to me and let me know exactly what you're trying to do. Of course, we can always set ground control, right? So at the MVP kind of minimum viable product would be if you're walking around doing your laser scanning, you may want to set a ground control target, something say on the ground that you've used either total station or a GPS to collect a very accurate X, Y, and Z. That target or ground control then helps geo-reference your entire scan so that both your accuracy and your precision goes up. So yeah, definitely could reach out and we could talk about it. Yeah, I think that's what we got, Bill.
Perfect. So just in terms of the next question with machine learning and AI for imagery and LiDAR, For any full ADA compliance, you obviously want to be using LiDAR and the highest accuracy information. But really where we fit in well together, Ecopia AI, is we're working with 1 million square kilometers of the 2024 aerial near map data to identify a high level set of features. And so this is for communities who haven't had the resources or the opportunity to even identify where your sidewalks might be, where are your crosswalks and medians. And so where we see ourselves is sort of the beginning phases of getting involved with an ADA plan. We want to be able to help you at a very large scale identify where these assets are, so it can help you tip and cue areas where there might be problematic pieces. Our organization is already working with 3 of the top 5 MPOs and over 100 communities and state DOTs across the country. And we've had the opportunity to work with a number of people on this call for a number of different kinds of transportation requirements. So I wanted to pass it off quickly to Brandon and Dr. Nicholas Smilovsky, just in case they had any additional pieces on the LiDAR piece. Because once you have a general idea of where all your assets are across tens of thousands of square miles, what are sort of the next steps?
Yeah, I really quickly, like if I'm understanding the question correctly, the way AI is usually used in conjunction with LiDAR is the segmentation and identification is typically done on the image, like the 360 image, or in the iPhone, just the RGB image, and then projected onto the LiDAR points. So you you cut out, your sidewalk panel in the picture and then project that onto the LiDAR information rather than taking a colored point cloud and doing the machine learning on the point cloud. It's just much more technically complex to do machine learning directly on the point cloud. It's also more challenging to create training data. So that's typically how it's done.
Yeah, I would echo that. I mean, there's lots of different ways. The one project, well, we had actually helped develop this tool where it was a manual selection. So imagine I had, I don't know, 20 technicians sitting behind, a bunch of screens. And just like Brandon said, they're in that panoramic view like Google Earth, and they see the panel. They would click the panel, and that's where the kind of algorithm would kick in, and it would actually take a cross section of the point cloud. It would auto calculate, your cross slope and your directional slope. It would then grade it and do all the different things that you heard through the presentation. So it was still manual but automatic. Now there are many softwares out there today that can go through imagery, go through point clouds, and it's that sample or trained data. It looks for something, a pole, a post, sidewalk ramp, and it can basically attack it. Now the problem becomes false negatives, false positives. What happens if there's a bush in the way? Jeff mentioned early on that one project had a ton of tree coverage or foliage, overgrowth. So what happens if a sensor drives by that? The computer thinks it's trying to do its best, but it misses the sidewalk because it can't interpret what a human can do. So a lot of these systems will get you like 70 to 80% of the way, and then you still need to have some type of engagement. But it does seem, and I know, Bill, you could speak to this, I'm sure, or even David, but like the AI capabilities are only getting better and better. I'll leave it at that.
Yeah. Oh, Bill,
Sorry,
do you want?
Yeah, David, go for it, because you have some of the most experience.
Yeah, I was going to say, like, some of the examples we showed were very small communities, like Mount Shasta and the like, where we did use Ecopia to start our data collection efforts, where I think there are lots of applications of understanding where are the crosswalks, where are sidewalks, at a very high level to prioritize data collection, where one strategy could be, if you get a very high level landscape understanding of where are we doing at a system level well versus not. And that's kind of what we were doing for those communities, where these were communities that did not have any of this information in a systematic in an integrated GIS database where they could look top down and say here, yes, no. And this is also a problem where a lot of ADA collection efforts are sometimes done within CAD, where you will sometimes have data collection efforts that are hard to integrate into a full picture of what's going on. across the city because of platform incompatibility issues or data incompatibility issues. And these are all things you really got to think about when you're thinking about how am I going to approach data collection for ADA in a systematic way. And so we often call what we call it a hierarchical data collection process, where there are just some forms of data collection, be it on mobile LiDAR, like mobile phone collection, um, aerial LiDAR, you name it, that are just more expensive per mile. That's just how they operate. But we need them to get that detailed information of what goes where. But if you start from the get-go with a process where you say, what's going on landscape wide, where are there critical gaps, you might be able to prioritize your data collection efforts in a way where they can do the most good for those issues or not. And that was largely the approach of Kansas City, where they had already quite a bit of information regarding their sidewalk inventory, the different condition of different facilities, but they really needed a way to get at that. Where do we focus next? Where are we building in the next 5 to 10 years? And do they need to do more detailed ADA data collection after that? Maybe, maybe not. But now they have a good landscape analysis to base that on. And so that would kind of be my advice when you're dealing with very large trade-offs in data collection efforts is starting at a high level, then zooming in is a good way to figure out where you can get the best bang for your buck.
Yeah, and that actually goes to one of the questions that's a little bit later down on the list, because you want to be able to use a balance of different approaches so that you can balance off the accuracy pieces with being able to understand where you need to be spending your time. I want to try to quickly sneak in 2 more questions with the limited amount of time that we have. Nick, quickly, can you explain how GNSS is better and more accurate than GPS?
Yeah, super fast. GPS technically is just satellites from the United States, global positioning systems from the US government. GNSS is an archetypal term where it's global navigation satellite systems, so you're accessing multiple countries' constellations. So more satellites, better accuracy.
Great. Thank you so much, Nick. We'll try to get 2 more in quickly. Deep walk question. You may have covered this, but we use the CORS network. Do you connect the iPhone to RTK while scanning sidewalks?
Yeah, so any of the devices that connect directly to phones, Bad Elf has a setup for doing it. Dribble does. There's several providers. Any of those that replace the GPS reading in the iPhone works.
And the next question, Esther, this must be terribly unfair, but how do you balance the design aesthetics in cartography, apps, and accessibility?
Esther, you only have 30 seconds to answer that
Right?
entire question.
No.
So sorry.
No, you know what? There's a really great answer for this. It's where the science becomes art. There is no answer, but Esri loves surfacing this kind of stuff. So when they create a map that they're really proud of that's compliant, they surface it. So in that link that I provided, you can look at all of their examples. It really helps to see how someone else has done it in the past. So go check out their examples. They love to show off.
A+, to sneak that in. Well, I know we're coming up on time and I want to be respectful for all of our attendees here. I want to thank everybody today for their participation and all the questions that you provided. There's a lot of resources online that are part of this webinar, so we please encourage you to go there, that have been provided by all of our presenters today. And I wanted to thank everybody again and looking forward to communicating with all of you potentially in the future.